Limits at infinity, part 4. Going to look at some more quotients, so where you have one thing divided by another that involves some square roots. We have the limit as x approaches infinity of the square root of x plus 2 all over x minus 4. Trying to evaluate this limit as is, we end up with infinity over infinity, which is indeterminate. So we'll need to try out our strategy, where we multiply by the reciprocal of the term in the denominator with the highest degree, which would be x. Since this expression or function involves a square root, we'll want to rewrite this x as a radical. The square root of x squared is what x is equal to. So now we can multiply by the reciprocal of this. So we have the limit as x approaches infinity of the square root of x plus 2 over x minus 4 times 1 over the square root of x squared over 1 over the square root of x squared. We can then distribute this 1 over the square root of x squared to each term. In our numerator, everything is under this radical, which is the square root, and this is also a square root. In fact, we can think of it as this whole thing as being the square root, since the square root of 1 is still 1, which means we can actually distribute this 1 over x squared directly to each term inside of the radical. So we have the limit as x approaches infinity of the square root of x over x squared plus 2 over x squared, which we got to do because both of our factors had that radical. In our denominator, we don't have any radicals, so we'll just have to keep this in x over the square root of x squared. Minus 4 over the square root of x squared. And the square root of x squared is just x. So now as we simplify this, we have the limit as x approaches infinity of the square root of 1 over x plus 2 over x squared all over x over x is just 1 minus 4 over x. And now we should be able to evaluate this limit. So the limit as x approaches infinity of 1 over x is 0, and the limit as x approaches infinity of 2 over x squared is also 0. And this will all be over the limit as x approaches infinity of 1 is 1, minus the limit as x approaches infinity of 4 over x is 0. So we get 0 over 1, which is equal to 0. We have the limit as x approaches infinity of the square root of 5 plus 2x plus x to the 4th power, all over x squared minus 4. If we try to evaluate this limit as is, we end up with infinity over infinity, which is indeterminate. So we'll need to do some more work. Since we have this quotient here, and it even involves a square root, we'll try multiplying by the reciprocal of the term with the highest degree in the numerator. So that's x squared as I circled. And we'll just want to write this as a radical expression. So x squared is the square root of x to the 4th power. That way we can more easily deal with the radical in our numerator. So this will be equal to the limit as x approaches infinity of the square root of 5 plus 2x plus x to the 4th power. Now I'll draw my line since I know how long that expression is. All over x squared minus 4. And we'll multiply by the reciprocal of the square root of x to the fourth power. So that'll be 1 over x to the fourth, the square root of x to the fourth, and 1 over the square root of x to the fourth. That way we're just multiplying by 1 effectively. And as I look at this, I see that everything in my numerator is under this square root symbol, and I have the square root of x to the fourth. And I can actually think of this as a square root of 1 over x to the fourth, since the square root of 1 is still 1, so I haven't actually changed anything. And then I can distribute this 1 over x to the fourth to each term under the radical in my numerator. In the denominator, I don't have a radical symbol, so I'll just have to distribute the 1 over the square root of x to the fourth as is. So this will be equal to the limit as x approaches infinity of the square root of 5 over x to the fourth plus 2x over x to the fourth plus x to the fourth over x to the fourth over x squared over the square root of x to the fourth minus 4 over the square root of x to the fourth. Of course, I don't have any radicals in my numerator or anything, and that x to the fourth, square root of x to the fourth, pardon me, is x squared. Simplifying, this will be equal to the limit as x approaches infinity of the square root of 5 over x to the fourth plus 2 over x to the third plus 1 over, well, x squared over x squared is 1, minus 4 over x squared. And now it looks like I should be able to evaluate my limit. So the limit as x approaches infinity of 5 over x to the fourth is 0, plus the limit as x approaches infinity of 2 over x to the third is also 0, and then the limit as x approaches infinity of 1 is 1, all over 1 minus the limit as x approaches infinity of 4 over x squared is 0. So I have the square root of 1 over 1, which gives me 1 over 1, which is 1. We have the limit as x approaches infinity of the square root of x to the fourth power plus 2, all over x minus 4. Trying to evaluate the limit as is, we end up with infinity over infinity, which is indeterminate. So, since we have a quotient here, and it even has a radical, we will divide by the highest degree in the denominator, or rather by the term with the highest degree in the denominator. So that will be x, and since we have a radical, we will want to rewrite this as a radical expression, and x is equal to the square root of x squared. So this will be equal to the limit as x approaches infinity of the square root of x to the fourth power plus 2 over x minus 4 times the reciprocal of the square root of x squared. So that'll be times 1 over the square root of x squared over 1 over the square root of x squared. We have a radical and a radical, and we'll actually treat this as the square root of that whole 1 over x squared, since that's equivalent. So we can distribute this 1 over x squared to each term under the radical. We don't have any radicals for that x minus 4, so we'll just have to distribute the 1 over the square root of x squared as is. So this will be equal to the limit as x approaches infinity of the square root of x to the fourth power over x squared plus 2 over x squared all over x over the square root of x squared minus 4 over the square root of x squared. And these square roots of x squared simplify to x. Simplifying a bit more, we have the limit as x approaches infinity of the square root of, well, x to the 4th power over x squared is x squared. Then we still have our 2 over x squared. That won't simplify further. X over x is 1, and then we have minus 4 over x. And now it seems like we'll probably be able to evaluate this limit. The limit as x approaches infinity of x squared is infinity, plus the limit as x approaches infinity of 2 over x squared is 0. The limit as x approaches infinity of 1, wrong blue, is 1. And the limit as x approaches infinity of 4 over x is 0. The square root of infinity is still infinity, or rather approaching infinity. So we have infinity over 1, which is not indeterminate, it's just infinity. We have the limit as x approaches infinity of sine squared x over x squared plus 1, and we're trying to evaluate this. When you see a trig function and you're trying to evaluate the limit, one thing that you can try out is squeeze theorem. So if we look at this sine squared x, well, sine squared of x is trapped between 0. Oh, that's an ugly sign. Sine squared x is trapped between 0 and 1. All of the outputs will be between 0 and 1. Because normally, with just sine, we'd be between -1 and 1, but now we're squaring all those values, so they can only be positive. But they won't get any bigger than 1. And now we can take this sine squared x and try to make it look like this function here. In order to do that, we'd have to divide all the pieces of this compound inequality by x squared plus 1. And x squared plus 1 is positive, so we can do that without worrying about our inequality symbols. So we have 0 over x squared plus 1 is less than or equal to sine squared x over x squared plus 1, which is less than or equal to 1 over x squared plus 1. And we're looking, well, now at the fact that this function matches this function, and we're trying to find the limit as x approaches infinity. So we'll just take the limit as x approaches infinity of each piece of this inequality. So we have the limit as x approaches infinity of, well, this is just 0, is less than or equal to the limit as x approaches infinity of sine squared x over x squared plus 1 as less than or equal to the limit as x approaches infinity of 1 over x squared plus 1. And then we can evaluate the limits. The limit as x approaches infinity of 0 is 0. This is the limit that we're not quite sure of. So we just have to leave it in there and hope that we get an answer. And this is less than or equal to the limit as x approaches infinity of 1 over x squared plus 1. For this function, our numerator is staying this constant 1, but our denominator is getting larger and larger and larger and larger and larger. So this limit approaches 0. The limit as x approaches infinity, which I should have been writing, of sine squared x over x squared plus 1 is squeezed between 0 and 0. So it must be equal to 0 by squeeze theorem.